who couldn't make it tonight. And just some short housekeeping. Please all be nice to each other and abide by the WCRP Code of Conduct. Only use the chat if you've got like technical or sound issues. Beth is going to be putting in Padlet links for, there's a sort of Q&A board you can put in any questions and comments during this first part in the presentations. And it just means that it's easier to capture after, and we can then put together all the information. If you want to turn off your camera during the presentation, absolutely. If you want to sort of save bandwidth, that's fine. But please do have them on during the breakout sessions, because it's nice in discussion to be able to see people. We will be making all the event materials available on the workshop webpage after. And just to kind of say, this is quite an informal workshop. The idea is to get lots of ideas and questions and issues and challenges out. So, you know, it's not really structured. That's why we wanted to have plenty of breakout time. So we won't have kind of questions after each presentation, but do fire them on the Padlet with the Q&A, and we will be gathering all of them, getting answers and putting them available for everyone to see. So firstly, I'm going to hand over to Christian, and he's going to introduce the context of the workshop and just some of the objectives. So I'll hand over to you, Christian.
Thanks. I try to share the slide. Okay, looks good. Okay, so I think you can see the slides in the right. No, but it's okay.
It's just going into presenter mode rather than full screen.
So now it should work. No, does not work. Okay.
But it was doing it for a moment.
Ah, okay. Then maybe I switch back. Ooh. Okay, so that's strange because usually I think now it works. Yeah, okay.
Yes.
Okay, sorry for that. So yeah, good evening from Germany. I'm Christian from Deutscher Wetterdienst, so that's the German Meteorological Service. And I'm very happy to give the introduction for the workshop, explain a bit the scope and also the aims maybe and what we want to achieve by 11 o'clock Central European time, hopefully. Yeah, I think some words about the motivation for this workshop. I think the idea came up during some of the CMIP task force meetings last year when we recognized that there is really I will not say a problem, but that there are very different approaches in this model selection topic. And of course, most of you will know that nowadays, most of the climate service information, also policy consultancy and information for climate adaptation and so on are normally based on large ensembles of climate projections. And of course, the composition of these ensembles is very important for the information that is finally generated and then also passed to the users. But the construction of this ensemble and the selection of the models is not very homogeneous, I would say. There are very different techniques and ensembles used in different countries, different projects and initiatives. And that in the end leads to inhomogeneous and sometimes also contradictory information. And that, of course, when then used in climate adaptation and for political decisions in the end leads to inconsistent decisions and measures. And I've put some pictures here on the right side of the slide to give some very simple examples for that. So in Germany, we have 16 federal states, and the federal states in Germany are responsible for climate adaptation. And in the past, basically all the states produced information by themselves, which then leads to, as I said, to different information or different database they had in the end, and then that led to different information and also to very different measures in the different federal states. And now with this upcoming CMIP 6 ensemble, we are for the first time in the situation that we have brought that a bit together and homogenized that, but that was quite a long way, even for one state. It was very difficult to get this on common ground in the end. Another example is the DACH region, so the German-speaking countries, Germany, Switzerland, and Austria. So we have a very, very good collaboration with colleagues from Switzerland and Austria. And for many years, we are in good exchange about these topics, but we recognize that we also use very different databases for our climate service products. And Sven Kodlarski, who is also here in the meeting, will later on explain that in a bit more detail. We made a study on that in the area here around Lake Constance, where the three countries are very close together. And he will explain what the outcome of this study is. And then, of course, you probably know the CORDEX regions very good. And of course, in these regions, also the available ensembles are very different. So there are domains which large ensembles, many GCMs downscaled by many RCMs, but there are also regions where the situation is very different. And of course, this also is then in the end a very different database that is available for science, but also for climate adaptation in these areas. Here is a simple example from a project we had in the framework of the CMIP 5 downscaling some years ago in Germany. It's temperature, precipitation, scatter plots here for the RCMs that were used and the GCMs also. But that's not so important. On the left, we have the signals for RCP 2.6 and on the right for RCP 8.5. And I think everyone can see immediately that both ensembles are very different. So the RCP 5 ensemble is much larger. And of course, then when you compare the two scenarios, you will have differences that you cannot really explain just by the different scenario, but which are coming from just the different ensemble size and the different models that are used in this ensemble. And this is, of course, a situation we want to avoid ideally, and therefore it is really necessary to homogenize that a bit. And we have, at least for the EuroCordex domain, we have made really in my opinion, a great step forward here for the CMIP 6 downscaling with the selection, what we call the balanced matrix. And Stefan Sobolowski, who is also in the meeting, will explain that in more detail later on. And then another important point, in my opinion, is the time it takes from, let's say, the construction of the historical forcings or also the scenario forcings and the generation of the global climate simulations until the data reaches the end user. So here you can see on the left the timeline from CMIP 6. So basically they started in 2013, and then most of the simulations, they were delayed, but they were produced in 2019 mainly. And now it's 2025, and at least in Europe, we are in the middle of the downscaling process. And then if impact models are involved, it will take some more time to run these models. And then finally, in 1, 2, maybe 3 years, the data will arrive, the information and the data will arrive at the end user. And of course, the whole process then is more than 10 years, maybe even 15 years. And this is, of course, also not ideal. So there's also certainly room for improvement. So the main questions maybe for today: is it possible to streamline or even standardize maybe the model selection and ensemble composition across different projects, initiatives we have, and also different regions maybe in the world? And second, is it possible to speed up the process from generating the global simulations until the information is available for the end users. I think these are the two key questions for today. And of course, there are also some more aims maybe we would like to achieve in the next 2.5 hours. So of course, first we should maybe try to identify issues, challenges in the current frameworks, can be both scientific and technical. And then maybe try to develop shared understanding of the selection techniques that are used in the different communities, and then see if it is possible to really come to shared criteria for this model selection, and see if this is really possible to do this. We know from, let's say, the experience in Germany and also in the DACH region that this can be complicated, I would say. And then, is it possible to establish tangible structures to support improved communication between modeling centers and downstream activities? And of course, as I just said, accelerate the process from the creation of the global simulations until the data arrives at the end user. Also, if there are possibilities to get some funding for this, and also develop the scientific and technical frameworks that are certainly needed for such things. And then a last point, but maybe important, can we realistically assess if there is already something possible for CMIP 7, or if that's maybe too close and we should try to lay the ground somehow for applying the things we can maybe develop then for the next CMIP phase. Okay, the program looks like that. So we now have the introduction here, of course, and then we will have some talks afterwards. So as I already said, Sven Kodlarski from Meteor Swiss will give an example for this comparison in the DACH region, Germany, Austria, Switzerland, and what challenges we face there. And then afterwards, we will have the talk from Stefan on the CORDEX balanced matrix in CMIP 6. And another example from CORDEX Australasia from Michael. And then afterwards, two talks for ISIMIP from Celine and Lisa. And after the talks, we will go to the first breakout groups. I will explain that in more detail in a second. Then we will have a short break, and then the second round of breakout groups more on technical challenges, not so much on the scientific part as the first round. After the second round of breakout groups, we will join in the plenary again for feedback from the groups, short feedback from each group, maybe 2 to 3 minutes, and then for a final discussion and summary in the end. Yeah, the breakout groups for the scientific challenges, we will have 4 in both sessions. So the first part is for the scientific challenges. First and second breakout group are for the ensemble sub-selection about the criteria and evaluation frameworks. That's led by Silvina and myself. Then the third one is about what do development innovations mean for model selection, especially in CMIP 7 with emission-driven simulations, and also maybe AI ML topics. So that's led by Roland. And then understanding and quantifying and communicating uncertainty is the fourth breakout group led by Michael. In the second part, for the other challenges, we will have a first group on constraints on the availability of the required GCM-ECM model data, also timing, provision of required data, and so on. That's led by Sophie. Second group is sustained and supported infrastructure to store, deliver, and provide user-friendly platform for analysis, framework, and for coordinated exchange between the communities by Michael. Then the third one is about the speed up of the process from creation of the global simulations until the data is available for end users. That's led by me. And then last group in that block is the balancing competing needs, funding, politics, and ensuring equity and supporting training and capacity building in a global community effort. And that's led by Helen. Yeah, that's it from my side. Thanks for listening. And I hand back to Eleanor or directly to Sven, maybe for the presentation.
Thanks, Christian. Can just everyone make sure that they've got their microphones on mute, because there was a wee bit of background noise just then. So we'll hand over to Sven Kotlarski from Meteo Swiss. Sven,
Yes.
are you able to share
hello.
your presentation, or would you like me to do it?
I will give it a try. Can you, I assume you can hear me?
Yes.
And
very
maybe
well.
you can see the presentation now?
Yes, great.
Yes.
Thank
Okay.
you.
Okay. So hello everybody. This will be just a short presentation, and I think my job here is to help to set the scene by giving you one example where actually model selection greatly matters, and we're moving to Central Europe here, and Christian already introduced this thing. So we have a very strong collaboration of the, let's say, the three mostly German-speaking Met services of Germany, Austria, and Switzerland, and we're exchanging models, methods, know-how, of course, tools, and we all have our own national climate scenarios, and all of them are based actually on dynamically downscaled CMIP data. So they are all based on CORDEX data. I will show you some details in a minute. And now in this collaboration, we actually have now the aim to provide something more consistent across the borders, something multinational that is consistent in itself. And why are we aiming for this? And this is just one very obvious example here. That's the map of the drainage basins of the watersheds in Central Europe, and you see the boundaries of these watersheds. They don't align with the national boundaries. If you, for example, look at the River Rhine that originates in the Alps, Switzerland, Austria, Liechtenstein, Germany, and then drains into the North Sea. You have a fraction of France, Belgium, Netherlands there, and of course Germany. So this is a very obvious example. If you want to set up hydrological climate impact studies for the Rhine River, you need to have consistent scenario data for the entire catchment, and that spans multiple countries actually. Now to set up such cross-border scenarios, there are a number of challenges, and I'm just listing a couple of them here. It's not all of them for sure. I mean, we are independent entities at the Met Services. We have our different national timelines, often linked to adaptation strategies, for instance. We have different funding schemes. We have actually, in terms of monitoring, partly different standards, different monitoring grids. That's important for bias adjustment, for instance. We have different topics we focus on. An example is that sea level rise, it's not an issue in Switzerland or in Austria, but it's an issue in Germany, for instance. On the other side, like the snow scarcity of winters is much more an issue in the Alpine countries. So there are different focus topics, different set of indicators, and overall there's a big challenge is, and that is Christian already referred to this, is that we have in general, we want to keep the pace of IPCC, but we have problems because it takes a long time until we have the dynamically downscaled counterpart of CMIP available. Now, how do these three national scenarios look like? This is just an overview. I don't go into details. So you have different, as I said, different observational grids, different indicators, and also what differs actually, these are the current scenarios that we have, is the sub-ensemble of CORDEX that is used for the three national scenarios. So you have a more or less simulations available, and the sets are not consistent, and in each individual case, the criteria for selecting a certain set of simulations, or you have several criteria. It's the availability of simulations, of course, at the time when you start your national scenarios. You have usually a performance evaluation. You try maybe to have consistent ensembles covering different emission scenarios. You might have institutional commitments, that is using your in-house models, for instance, and for sure some further criteria that are relevant here. And what does it mean? And here's one example that Christian actually already referred to. Now, zooming into the part where the three countries join each other, that's a region around the Lake of Constance that you see here. That's a lake that is actually a shared territory of the three countries, about 500 square kilometers. So it stretches about 50 to 60 kilometers, the length here. And what we set up is a scenario where we say, okay, we have three big countries, three big cities, very close to each other in the three countries, like 10 to 20 kilometers apart. That's Rorschach in Switzerland and Bregenz in Austria and Lindau in Germany. And the case we are investigating here is if each of these three city administration would go to its national Met service and ask for climate scenario data for different indicators, changes into the future, what would they get and how would they differ? And we had a close look at that. And it's important to say these three cities, they are located within 2 to 3 CORDEX 12-kilometer grid cells, so they're very close to each other. There's basically no physical reason why climate scenario data at the scales that are resolved here by CORDEX should differ between these three cities. And here is one example. What you see here is the projected temperature change by end of the century for this common region that is covering these three cities by the three national scenarios. So blue is Switzerland, and yellow is Austria, and green is Germany. And that's the entire CORDEX ensemble available. So it's about 91 simulations. And what you see here is not only the effect actually of model selection, but also of the bias adjustment. So you only see the combined effect. But what you have here is that the entire ensemble gives you a warming by end of the century, RCP 85, of about 4 degrees Celsius. The Swiss scenarios, they are also at that value in their median, but the Austrian scenarios, you see that here, they have a less warming. In the median, it's about 1.4 to 1.5 degree less than what the overall ensemble gives you. On the other side, the German scenarios, they give a little bit a stronger warming, and the difference between these two is about 0.7 degrees Celsius. So that is substantial. That's for temperature, and here's another example. That's for annual mean precipitation. You see here there are no large changes projected. The entire ensemble gives a very slight increase, but basically stays close to zero. But what you have here is the Austrian scenarios, they are much more on the positive side. The median, at least, and the median of the German scenario set is on the negative side. So this is kind of contrasting information. And here's the last example, and that's a typical climate indicator. It's the change in the number of summer days. That is days where maximum temperature is above 25 degrees Celsius. And you see all of these national scenarios, they would provide an increase of this number of summer days, but the strongest increase, about 60 days, is given by the German scenarios, and the Austrians only give about 45 days of increase. So the bottom line here is that obviously in this three nation region, model selection highly matters. So in this case, model selection and bias adjustment, as I said. So you see both effects here, but if you try to divide between these two effects, you see typically that model selection is a dominant effect. So the reason behind the differences that I've shown here is basically model selection, differences in the model selection. Now, to finish, some ways to move forward. What we try in these three countries and a bit in a wider range is to harmonize a bit the national frameworks, like to use the same time frames, the same reference periods, the same or at least similar indicators, for instance. On the, let's say, European scale, and Stefan will talk about this in a minute, I think, we have now started a joint evaluation of new simulations and also have a joint model selection. That's a big step forward, I would say. And also we try to collaborate even further on this topic in the DACH weather services. I mentioned the delay in the availability of dynamically downscaled ensembles, so a more rapid update cycle here would be very welcome. And also, this is something that we refer to as climate information distillation, also to better integrate statistical downscaling and also high resolution GCMs actually into the mainly CORDEX-based assessments. So incorporating different sources of information, of course. For CMIP, I think a relevant point is this faster provision of RCM forcing data to speed up this process. The dynamical downscaling process would be very important, very welcome. And also already well-informed GCM selection that we now did in Europe in a separate initiative. But if already the GCM data comes with a certain quality assessment and maybe even a selection, and would be cool. And if this selection is consistent for different emission scenarios, so this kind of same models for different emission scenarios to be consistent in this comparison would be also very good. And there are many more points, and I hope we can discuss some of them at least today. So that's everything. Thanks a lot.
Thank you very much. Then we might have time for one question if anyone had a quick one. We're a little bit ahead of time.
There is one from Michael in the Padlet.
Just say it live if you like.
Perfect.
That analysis of the difference in the scenarios in these different places that should ideally be consistent are confusing and annoying for users for sure. But if you take it through to the policy, like does it actually suggest a different policy in different regions in terms of adaptation, or is it kind of in the noise in that regard?
I mean, that is something we didn't actually investigate now. We didn't drive it that far. But let's say if you have qualitative differences in, I mean, annual mean precipitation will increase by 10% or decrease by 10%. I think that's already in the range where it's quite relevant for policy. But we didn't drive it that far. Yeah.
Thank you very much. Stefan, you're up next.
Yes, thanks very much, Eleanor. Let's see here. Do I want to do screen or do I want to do application? I'm not sure. Let's see here. Give me a moment here. All right. So let's go to that. So I've just adapted what's been now a long-running presentation, and I'll run through it very quickly because I think we've seen what kind of the problem is, and I'll jump rather quickly to the solutions that we've come up with for EuroCordex at least, and the tools that we've developed now, which hopefully in the next round can be applied more quickly. But I think Christian and Sven did a nice job of sort of setting the stage of and the scope of the problem. And basically within EuroCordex, we recognized that in some respects what we did with CMIP 5 was very much an ensemble of opportunity. We're missing parts of the GCM ensemble, and also there wasn't a whole lot of, I guess one thing that wasn't touched on is the fact that there wasn't a whole lot of investigation of process-based metrics. For example, how biased certain GCMs may have been with respect to the positioning of the jet stream, for example. That's very relevant for Europe, or biases in other terms. So we set up a task team to take care of this, and it's been a long process. And so basically I won't go into details on here. This is all some of the background and why we need this. And we came up with 4 selection criteria, basically, for GCMs for driving the EuroCordex ensemble. One was the data availability and quality, so making sure that the driving data is available, that it's been that it's in the right formats, and that it's available for all of the available SSPs, for example, so that comparable investigations can be done. Basic Q&A is done, so missing values, suspect values, etc. Then a plausibility criteria, so this is where process-based metrics come in. And then a third criterion on exploring the range of future outcomes. So this is to ensure that we are sampling from the distribution of possible outcomes in terms of, for example, transient climate response, and also dynamical responses as well that are relevant for Europe. And then the fourth criteria, sorry, I was jumping ahead. The fourth criterion was about kind of everything else, I guess I would call it. So things like the resolution of the models, the model family tree, so that we don't take models that are too close to each other in terms of sharing components like atmosphere or ocean, etc. So I will jump through these because this is all just background. So model diversity, unconstrained and constrained temperature. And so what we wanted to do also, though, is to make this process traceable and transparent as possible, recognizing that any way that we were to slice this up, it would still involve subjective decisions, and there's just no escaping that. And we wanted to be very clear about that fact, and to have it be available to potential users of the ensembles. You know, what went into the decision making, what the relative strengths and weaknesses of the GCMs that were chosen are, and then also being clear about why we made the decisions that we ended up making. And those decisions may be different for different regions of the world, for example. We've set up a system that is you know, more than just numbers, that also has decision thresholds and a discussion, and that's both machine readable as well as human readable. And at this point, I should give a you know, a real shout out to Jesus Fernandez, who really did a lot of heavy lifting to make this thing a reality. And I'll show very quickly how it all works in a moment here. So basically everything's available in markup language and in files, and we're able to assess how these different models perform, and then perform a you know, a ranking or an outcome. And this is just an example from the paper that's in review now, hopefully almost done. And there are something like 20 different metrics that these are evaluated on. Of course, not all models are evaluated for all metrics, because this is all done through a literature review. It's not, you know, we can't do all of this evaluation ourselves. And for Europe, at least, we really wanted to make sure that we were sampling from the range of global temperature outcomes. And so our stratification on the right is according to the plausible range from the IPCC of the transient climate response. But also recognizing from stakeholders that it's desirable to have some worst case scenarios out there. And so you see the inclusion of some models at the bottom that are outside of the plausible range, although, to be honest, not very far outside of that range. So onto this balanced matrix idea that Christian was talking about. So for this, we have to give credit to Guillaume Even, who suggested that, and we're not the first ones to think of this too. I should also mention the NARCAP initiative in the United States used a factorial regression approach to not try to fill out the matrix of possible combinations of regional models and global models by filling in every empty space, but to take a statistically robust approach to fill it in a balanced way. And so we've taken, and also acknowledging too that if we were to fill the full matrix, which was done through the Principles project for Europe, there's no impact modeler out there that's going to be running their impact models for every available simulation. It's just computationally way too heavy. And so the idea was to have a subset of the larger ensemble that is balanced. So it samples the range of global warming outcomes, and also with plausible models and the combinations of regional climate models. And so we have now an set of simulations that are a subset of the much larger CORDEX ensemble that's a balanced matrix, and that's much more tractable for downstream users of this information. This is now quite dated, so I didn't have time to update it today. That's the balanced matrix, and I can just very quickly show people how this looks in practice. Hopefully people can see my screen. Can you still see my screen, folks?
Yes.
Yeah.
Good. So this is the GitHub site, the GitHub website, and you can see that the boundary conditions availability.
Still the slides, Stefan. So
oh, still the slides?
Maybe you shared the application. Maybe you should share the screen.
Yeah, yeah, let me do that. Sorry, folks. Let's go back. Let's share the screen. Here we go. Oh, yes, that's what I wanted to do. Sorry. Now can you see the website?
Yes.
Okay, great. So this is what the website looks like at the front. It's now been done for the availability, performance, and spread tables for the different domains. There's 4 domains that this has been done for: Australia, Europe, Mediterranean, and Southeast Asia. So if I click on Europe, this is what the summary tables end up looking like. It's not very readable for you all probably on small screens, but you can see that it's quite comprehensive. If we look at these are all the different criteria. So the availability, where my cursor is clicking there, the plausibility criteria over here, there's about 20 of them, spread of future outcomes with a traffic light system, and other criteria like model diversity, atmospheric resolution, etc. And all of these are underlaid by files that folks can then go into and see what lies behind the metric, what the values are, what the ranges are, what the plausible values are, and also comments as to why we made a decision as far as thresholds. So you can see down here, this is for performance criteria, so past trends plus spatial patterns. This is from Lucas Brunner, I believe. And then we can blame Sam Samo for the threshold value choice. So that's pretty much it for me. This is a living system that is open for use by not just our community, but any other community who wants to make use of it. And yeah, and I think that's enough from me.
Thanks, Stefan. So again, we're a wee bit ahead of time. So one question, there's another Stefan with a question, with a hand up. Go ahead.
Yes, great presentation, Stefan. I'm curious, this ranking, it's very process-based, which I'm really happy to see as a dynamical downscaler. I'm wondering how you all have balanced, how folks are thinking about balancing process-based metrics versus like mean biases. So for instance, one might think that the general circulation of the atmosphere, like where the subtropical and polar jets are located, for instance, may be very well simulated in a climate model, but that climate model might be operating in an atmosphere that's 4C too cold, or even 2C too cold conditions. And so when you feed that 2C bias in the mean state to RegCM or WRF, for instance, you get really kind of, I would say, nasty results. And I'm wondering how the rankings that you just presented on, how they kind of balance this process versus mean state metrics, because I've seen literature out there that, evaluates, GCM biases in the mean state, and then other studies out there that evaluate process-based biases.
Right. So so we do have metrics that do account for biases too. It's not all just process-based as well. So there are metrics in there that are related to representation of temperature trends, for example, also for temperatures over the region as well.
Okay, that's awesome. Thank you so much.
So it's and it's all, but this is something we'll discuss in the breakout rooms too, though, is like, can we come to like a, an optimal set of metrics, because it's potentially an infinite list, which is not what we want.
Thank you so much.
Yep, thanks.
Thanks, Stefan. Now we're going to move over to Michael.
Eleanor, I'm just attempting to share screen.
Yeah, we can see your PowerPoint. It's just not in full screen.
How about now?
Yep, perfect.
Great. So yeah, I'm going to give a little bit of Southern Hemisphere perspective, and we're on a very similar set of issues and track really as the previous presentation, but perhaps at a bit of a slightly smaller scale because we don't quite have the resources that EuroCordex does. We wish we did. So I'm kind of presenting on behalf of what we've formed, a national partnership for climate projections, similar to Germany. We've got a few different efforts going on, and we're really trying to get more coordinated and organized, so that we can kind of have a more balanced and more complete set of modeling available for all of us. So a few years ago, we kind of held a workshop and a process to decide what would be the best strategy for new projections, and there was decided that coordinated multi-model, multi-scenario regional climate model ensemble is an important enough or valuable enough resource to prioritize and to produce to inform new national projections, and then also be available for states within Australia, and complement that with analysis of CMIP6 itself and large ensembles and other information sources. And of course, following CORDEX guidelines gives you that benefit of international benchmarking and comparability. And this, of course, requires model selection, the topic for today. And we actually included 3 different independent or semi-independent kind of stabs at this. And that was actually useful because then we could compare what different groups came up with and what they found, and whether they were the same and whether they were different. So of these 3, I should say we end up with a similar situation to what EuroCordex has there, which is kind of a semi-organized, not as organized as EuroCordex, but semi-organized sparse matrix of RCM and GCM combinations. So of the selecting studies, all of them were quite similar and kind of becoming fairly standard, I get the feeling of, which is, data availability is the biggest first hurdle, but then after that, evaluation, independence and representativeness, those 3 kind of broad criteria. And evaluation was used to reject unsuitable models, not select the best few. And we were really interested to discuss at this meeting about choices to reject and how to decide if it is meeting a minimum threshold, and can those thresholds be set a priori and objectively rather than just seeing when it comes out generally at the bottom. I think that's an important kind of question. Independence, just a simple approach, just trying to kind of choose models that are above a threshold of not being too similar. And then representativeness, which is like the spread of projections, making sure it's representative of the host ensemble at some scale. We generally looked at rainfall and temperature spread, and also had a consideration of the hot model problem and climate sensitivity, but then also some consideration of the main circulation and drivers that affect our climate. So for example, the position and intensity and change in the subtropical ridge and the monsoon shear line, which are important circulation drivers for future change. What we ended up with is that table on the right, which has got some gaps, which is intentional in a way, but then also some which have got some consistent choices all the way across, which actually of some key models. So which is actually going to be useful to tease apart the effect of the different regional models and what they do. And that includes ones that at each end of the kind of plausible range of rainfall projections and temperature. So some of the differences in the 3 studies that were done, and these kind of reflect important and I think interesting questions for debate and discussion today. So statistics, similar to the previous question actually, statistics of the surface variables themselves and the mean bias versus some focus on drivers and processes, how to kind of balance those 2 considerations up. the domain of evaluating mean state statistics, over the Australia itself or the much broader region, what's the most useful domain, and then also different measures of how representative the model ensemble is of the signal. So what indices to use and what region to assess it over as well. Some of the innovations that we feel we brought to this exercise. So for the Australian access model, we could select the realization that we wanted to use and request them to rerun their model and produce sub-daily data. We couldn't actually use run 1 to 3, so we actually chose from between 4 and 40, and we ended up selecting R6. This was a really interesting exercise to think through. If you can select an ensemble member, which one would you select? And then we also have quite a diversity of regional climate model configurations. We've got including the global variable grid atmospheric GCM, CCAM run in different ways. And then other people have tried SST bias correction versus not, and surface ocean coupling versus not. So that's kind of going to assess a few different options of how to run regional climate models. Known limitations of the studies that we've performed, and it's we know it's not going to be a representative sample for all applications. It may be pretty good for rainfall, temperature, some broad circulation changes, but it's not. We didn't consider land surface, carbon cycle, 100 other things in terms to see if it's representative for those applications. And of course, ensemble generation is really messy. On CMIP 6 itself is an ensemble of opportunity, then we're subsampling that, and then we couldn't go to the extent of making it statistically balanced, although I'm going to check out that GitHub page for Australasia that you've got and see what you've got there. And then we'll have a lack of intercomparability with other regions. We'll have a different model list from other CORDEX regions, so that's kind of a limitation. Barriers that we found, and the big question, can they be reduced for CMIP 7? So we could only choose from a small number of the full set of CMIP 6 models with that, because they didn't provide the sub-daily data from the 2 SSPs we focused on for us to use. This was overcome by one of the groups, the Queensland Future Climate Platform, which used a technique that was adapted to use only daily inputs. And also there's only one realization from most models. I guess the big question is it even possible to provide more models and more ensemble members, because it's used a lot of data, and perhaps in the next generations it'll be overcome by models could at least provide enough training data for machine learning to overcome that barrier, rather than full production runs of sub-daily data. I think that's an interesting question. There was also a lack of centralized comprehensive lists of things that we would love to just get off the shelf rather than redo. So climate sensitivity, you find that on the GitHub page over there because someone told you about it. The model evaluation studies, you just go and search the literature. And then independence, you found a family tree and the additional material from a paper over there. And all of them have got a different model list, and none of them have the whole set of models. That's a huge frustration. And no, as I mentioned before, no objective criteria to reject models. I would think investigating moving to kind of a benchmarking framework where you actually set those thresholds a priori and objectively. But that's obviously a difficult task, but I think it's worth pursuing. And then I guess the other thing that occurs to us is understanding the physical basis for the response to forcing, and then the added value in the signal. And that's a really important question that can we address that, and what does that mean for model selection? I just thought I'd kind of, in this idea of having a common model list in different parts of the world, here's just using the IPCC Atlas results for very high scenario by end of century, spread of projected change in just temperature and rainfall. Here's our model selection in the bottom there. Including the models that were rejected in red, and models with the data unavailable in grey, and then the blue is the ones we selected, and kind of just a line put around the space that we cover. We can see it's not too bad. The majority for Southern Australia, it's majority are showing decrease, which is the kind of assessed likely projection. But we also sampled the wet outlier, which couldn't be rejected. If we just blindly applied that to 3 other regions, then we can see that it wouldn't be a very representative kind of set for West Southern Africa, there's a big missing area. It would be not too bad for Northern Europe, and kind of not too bad for Eastern North America, except it wouldn't sample these models, but these didn't have the data available anyway. So I don't know, this kind of makes me think that, applying the same set of models, you would need a bit more, a greater number, or else you might have to set a core set of models, but then allow each region to select a few more to fill out the full projection space, at least by this metric. So I hope that's given you a bit of a flavour of kind of the process we've been doing in Australia to produce, a CORDEX model set for then use in climate services and climate projections for Australia. Thanks.
Thanks very much, Michael. I think we better move on with the presentations, but if anyone's got questions for Michael, if they put them up on the Padlet, and he can maybe go in and answer them there, and the same with our other speakers. So next up we have Cecilia Gosta from ISIMIP 6 and 7.
Yeah.
So if you can just share your presentation.
Oh, I cannot. Okay, community sur l'application. Okay, I am in the. I don't have the app, so I cannot share my screen. Yeah, maybe you can share my. Okay, perfect.
We just go to.
So yeah. Thank you. Yeah, so I'm Cecilia Gosta. I'm working at LSE in the Parisian area. So it's a lab from the IPSL sector. And I work on the forcing selection for the ISIMIP project. So ISIMIP is the iSheet model intercomparison project. ISIMIP 6 was the intercomparison project done for the CMIP 6 exercise. And now we are working on, not me, but so people are working on the ISIMIP 7 exercise. So in this exercise, you have many iSheet models that have to run, and with a common set of forcing. These forcing are coming from climate models, so CMIP models. This forcing can be from atmosphere, from atmosphere and ocean, because the iSheet is forced from both the atmosphere and the ocean. So you can go to the next. Yeah. So in the atmosphere, for example, the main forcing for the ice sheet is the snow accumulation above the ice sheet, because it's the mass gain of the ice sheet. And you also have the mass loss by snow melt at the ice sheet margins. And the surface air temperature is also an input of the ice sheet models. Then, if you go to the next, you can directly derive this forcing from CMIP models if you want. In fact, they will depend on many things, including the large-scale circulation in these CMIP models, the sea surface conditions in these models, and also it will depend on their polar physics. So the clouds, how they model clouds, the snow, the boundary layer over the ice sheet. So the approach we usually want to do is to use a regional climate model in between the CMIP model and the surface field we want. So it's the next slide. These regional models, they have polar specific processes. So they better model the snow, the clouds, the boundary layer of the ice sheets, and they also have a better resolution. But we can have both approach, either using directly the output of the CMIP model or the downscaling, any downscaling. So in ISIMIP, we decided to evaluate CMIP only on the basis of the large-scale circulation, meaning the input of the RCM. So we evaluate fields above the boundary layer, and we evaluate also the sea surface condition in both the polar region. So next. Yeah, and it's really important because in fact, there are many studies showing that the current state of the GCM at present impacts the climate change in the future. In the next slide, you can see from a study of Breast-Girdle that the current sea ice area in the model, so what the CMIP model do as a CS extent at present in Antarctica has a big impact on the climate change in Antarctica, meaning that the model with the largest sea ice area, they will have the largest increase in temperature in the future because they will have a larger decrease in sea ice. Next. Yeah. So in fact, in ISIMIP, we just really did the basics of model selection. So really the mini CORDEX selection, I would say, meaning that we only evaluated the mean state of the CMIP model at present compared to a RNA analysis. And we evaluated 8 variables for the atmosphere, for example, including temperature at different pressure levels, humidity integrated over the column, the atmospheric column. We evaluated the surface level pressure and the surface ocean condition, but all as a mean state. We didn't have any dynamical metrics. And we did that for CMIP 5 model, and then we updated it recently for CMIP 6 models. And we did it for both regions, both for the Arctic and the Antarctic regions, and also for seasonal and annual values. So then in the next slide, what I want to highlight is that we decided to use, as we have to get a score by CMIP model and by region, we had to average the metrics to have a final score per CMIP model and per region. And for this, we had to scale each metric by something, and we decided to scale it by the median RMSE of the spatial RMSE for each variable. So we compute the RMSE for each variable and each CMIP model, and that we scale by the median RMSE. And then we average this to get a final score. So at the end, our final score is just a ranking of every CMIP model with regard to the median or to the other models. And then in the next slide, finally, we decided to keep only the best half for both regions, the Arctic and the Antarctic. And here again, it's a choice we just decided to do because we had to do a choice. And then among this best half for both regions, we decided to select in the next slide a range of climate change over polar regions, a range of models that explore different climate change in the future for the polar region. So to my last slide, yes, thank you. Is about what can we do better. We can do many things better than that, but what I would say would be the main priorities would be to replace the relative metrics we have for each variable by absolute metrics. For example, in the history matching, you have the implausibility criteria that gives you, that tells you if the model is really plausible or implausible. And then you can only discard implausible model and not just the worst half. But it really requires a quantification of uncertainty on both the model side and the observational side. And last, the second thing is that, in fact, for this kind of exercise where you have to select forcing for a MIP, then you want to extrapolate the response of your ice sheet model forced by these few models to the full forcing from all CMIPs. And in that case, it means that you want to be sure that you sample really a diversity of sampling of inputs that impacts the output of the ice sheet model. So at the end, it will be good to revise what we had in the ISIMIP 6 model, the relationship between the inputs from climate model and the output from ice sheet model to, in fact, sample, really know the criteria to sample the CMIP base. And that's all.
Thank you very much, Cecile. Again, we'll need to move on, but if you have questions, if you pop them in the Padlet, and Cecile can maybe go on and answer them there. So we're now moving on to our final presentation before we go into the breakout groups, and that's from Lisa Novak from PIC, who will be telling us about the ISIMIP approach. Lisa, we can see your screen, but there's a sort of sub-screen with a presenter view in it. Yes, perfect. I don't think we can maybe hear you though. No. Maybe just try if you go to the audio options. Should maybe going out and coming back in again. Let's give it a moment. No, we still can't hear you. Is there any questions for Cecile just in the meantime? Frederic, you've got your hand up?
Yes, hi everybody. Thanks. Yes, my question is for the use of ISIMIP. Yes, to simulate ice in a CMIP model. So, yeah, I want to know my question is for Cecile, if this model can be applied to another region except the Arctic and Antarctic region. And
you mean the selection process?
Yes, the ISIMIP process. Yes. Do you think we can apply it for another region except for Arctic and Antarctic region?
I think you could apply this same basic metrics for other regions, including I don't know in the tropics, because in the polar region it's really sensitive to the circulation pattern. I mean, but in the tropics, I think maybe you would need to include other criteria. But I mean, this method is really easy to use, and yeah, you can apply it.
Okay. And what do you think what do you think for those who are studying using directly CMIP variable related to the ocean, sea level, without doing maybe this question is not for you, it's for the those who present the presentation on downscaling, because downscaling is I think is more useful by those who are working on land, on continent, where the borders are very narrow. So, but in open ocean, you think it is necessary to do the downscaling? And my last question is I didn't hear about the bias correction. So what do you
Sorry,
think about
Frederic, I'm just going to, it's just because time is moving on. Maybe you could pop that last question just on the Padlet.
Okay.
Lisa, do you want to try again to see if we can hear you?
Can you hear me now?
Yes, we can.
Okay.
Perfect.
Sorry, I tried everything with the computer. I just called in now. Let me share my screen again. Okay, can you see the presentation?
Yes, we can.
Great. Okay. Yeah, I'll also keep it quick because I think most of the things have already been said. So yeah, I'm from the ISIMIP data team. ISIMIP is the intersectoral impact model intercomparison project. And I'll tell you how, yeah, we select the models. So usually it's, we want the latest CMIP impact simulations for the next IPCC report. So we kind of have to select models before all of the CMIP, before the entire CMIP ensemble is out, so that we still have a chance that, yeah, the simulations from ISIMIP can also be taken into account. And the first thing, of course, is the data availability. So we look at the atmospheric data that we need, which is all of the variables that you see here. We need them on a 0.5 grid, degree grid, and we need them on a daily resolution for all of the scenarios selected by ClacierMIP, and we need at least 500 years of PI control simulations. We then check for further data like oceanic forcings, which we need for our fisheries and marine ecosystem sector. But when we check that for the currently running round, at the time that we had to select the models, we had less than 5 models to begin with. So this is not like a hard criteria that we check for. It's just good to have it. And then we also check for the input data that we need for tropical cyclone modeling. Then we look at how the GCMs reproduce the observational data. This is done with the evaluation by the ISM-BAL tool. And from the 17 GCMs that reproduced the observational data well, only 4 provided the data at a daily resolution that we need. But we do want at least 5 models. So we chose one extra model that has an at least average performance in the historical period. And from these models, one of them doesn't have the data that we need for the tropical cyclone modeling, but it does provide the most comprehensive oceanic and biogeochemical forcings, which is why we chose it, because most other models cover either less or only partially the variables that we need for the ocean simulations. We then look at the structural independence and at the representation of feedbacks. So the 5 GCMs that we have are structurally independent in terms of their ocean and atmosphere model components. They have coupled climate and carbon cycle, and some of them have fully interactive chemistry and aerosol components. And then we favor models that applied prognostic couplings between processes and model domains so that we can maximize the coverage of simulated feedbacks. In the last step, we look at the equilibrium climate sensitivity. So the 5 GCMs that we have, the mean ESC matches the mean of the multi-model mean from CMIP 6. So 3 models have a below average ECS and 2 models have an above average ECS. But we really check that we represent the mean of the multi-model CMIP 6 simulations, but also the entire range so that we don't just kind of choose models with the mean ECS. And the transient climate response is also precisely met. There is a paper though, so ISIMIP looks at impacts which are quite often regional. So there is a paper that came out last year that actually looked if the equilibrium climate sensitivity is important as a criterion for model selection. And they came to the conclusion that it's not really, because as you can see here, we look at flood events, at droughts, and at fires, for example, and the ECS says little about the regional impacts, which is what we want to study. So they recommend that you don't disregard a model just based on the ECS. So for example, if it's higher than what is assessed by the IPCC as the likely range, you can still use it to model on regional scales, which is why we try to really represent the full range of the ECS of the CMIP models and not just the mean. And I think, yeah, that's already it from me.
Thank you very much, Lisa. Now we are going to move into breakout groups. So Beth has set up the people who had already put in their preferences. So in a minute, you will automatically disappear off into the breakout rooms. Everyone else will then should get an option come up and they can then select their breakout rooms. Just as a reminder on the which ones you are looking at. So we have duplicate breakout group 1 and 2 with on ensemble sub-selection, so either with Christian and Annika or Silvina and Sarah. Group 3 is going to be Roland and I looking at what the kind of model development innovations are mean for model selection. And then the 4th breakout group is about understanding, quantifying and communicating uncertainty, and that's with Michael and Beth. So if Beth can just get the breakout groups going, we will go for 30 minutes. So about 5 minutes warm up for everyone to get in, a bit of intro from the chairs, 20 minutes of discussion. There'll be a Padlet for each group where people can write, but we want oral contributions as well. And then 5 minutes at the end, you need to focus and get your feedback done, ready for the feedback later. Okay, right, we're ready to go, I think. So if Beth can hit the button, I'll stay on for a minute to make sure people are managing to get out to rooms. Okay, welcome back everyone. Apologies for those who got stuck. I hope you then managed to join the discussions. So now we're going to move to the feedback. So we'll just go numerically. So we'll start with breakout group 1, which was Christian and Annika.
One second, I'm sharing. It's jumping between the slides here. Is Christian here?
Yeah. Okay, this was the first breakout group on the criteria for the ensemble selection and the framework. Can you please switch to the next one? Yeah. Okay, so of course, data availability is always a topic there. So this is usually the first step, and then once the models that provide the necessary data are identified, then other things can be applied. Then it was also mentioned that the emission scenarios play a role. So it's not only about the selecting the models, it's also selecting the right emission scenarios, and this will probably be more difficult in CMIP 6 because we will have more scenarios and there will be a lot of them on the lower end, and then maybe distinguishing between them will be a bit more difficult than this was in CMIP 6. Then this was, I think, a suggestion from Jose, which is, I think, very good, that in general, we should maybe try to find a common set of criteria that can be applied across all regions and activities. Information for that can come from, for example, ISIMIP tool and from the rapid evaluation framework that is applied in CMIP 7. But then it is certainly necessary to add more specific criteria for different regions or for different applications or questions, maybe in the end also for end users, to then be able to have the final product more consistent to the needs of the end users or the different regions. And this is also maybe the last point here, similar. So we should make sure that the best models for certain regions are not excluded for some reasons. So leave some flexibility there for the decisions. Yeah, for the collaboration, of course, it would be helpful to have maybe more frequent meetings and better coordination between CMIP, CORDEX, ISIMIP, and also all the other larger initiatives that are interested in this, to exchange the information. It was mentioned that it would be good to know, at least from the downscaling side, to know and to get frequent updates on the status of the production of the global simulations, if there are delays, when the data can be expected, and which groups will store the necessary boundary conditions at all. And then I mentioned it already on the slide before, but I think it's worth to mention it again. So the ISIMIP tool and the rapid evaluation framework might be very good starting points to generate the information and the criteria that are then necessary to take the decisions. And these things are already in place more or less, or will be developed anyway. So this is certainly good to use this as a starting point. And then for the next steps, establishing the meetings I mentioned on the slide before, this would certainly be necessary. And then also to get in contact with the ISIMIP group and the developers of the rapid evaluation framework to see when the things might be available and to come up with a plan and a timeline for that. And again, the modeling centers should provide the information to the downstream activities and especially report any problems or delays, and that the groups know what can be expected and when. I think these were the main points from Record Group 1.
Thank you, Christian. Okay, for the next, Sofina and Sarah.
Thank you. Thank you, Eleanor. Sarah, could you share the screen? Okay. So we had a very, very interesting discussion, and I will go through the main summaries. So first, we discuss these key issues. I'm not reading well. We have not talked about funding, so maybe this is not.
Sarah, is this maybe from your break at Group 8?
Yeah. This is not the presentation that I should be talking about. Yeah. Okay. And now it is. So for the question challenges, we first discussed whether we need a common criteria for model selections. It was raised by one of the participants, and we finally agreed on from different points of view. It is really needed mainly because CORDEX, the CORDEX community can now downscale everything, and we need to identify what is worth to be downscaled and to be provided for impact studies, depending on several criteria. And on the criteria, we discuss long, very in depth, and we finally agreed on having a sort of families of criteria for creating a framework or guidelines for selection. Families of criteria based on different aspects, and we can use the examples provided during the presentations, combination of those different criteria from the global modeling community, the regional modeling community, and the impact modeling community to try to design guidelines for model selection based on common metrics for some aspects of the models, some regional metrics specific for the different regions, and the one of the important issue here is to be transparent in the process of model selection in terms of showing the world why the selection is made like it is, in order to explain what have been the basis for making this model selection for each region. Then we also discussed whether these model selections should include both global and regional criteria, based on some experience on criteria already prepared by other initiatives. Second slide, please. The next one. Continue with the challenges and key issues. We could not find any consensus on identifying the best criteria, and that's why I mentioned this about trying to combine the lessons learned from other exercises and taking into account what limitations they found when using the criteria for different purposes. So to come up with a more or less agreed protocol or guidance. Then we also mentioned about the observational data sets that should be used for assessing the models, for instance, and we talk about including a number of reanalysis and local regional data as well. Next, please. In terms of the role for collaboration and who should be involved, the community is already collaborating in terms of this model selection discussion. So maybe we need to incorporate the user communities together with the global and regional model communities to improve this guidance, this guidance for model selection. And also don't forget to include experts from the different regions, because sometimes the criteria for some regions is not always applicable to other regions. We have had this example here from polar regions, from extratropical regions, and we haven't heard about tropical regions here, but the main issues for model selections are different. So we need to include regional experts in this discussion. And then we need to have a stronger collaboration, of course, with the global modeling community. Next, please. And the next one is shorter. We got out of time in our last. Oh, we have some suggested actions. What happened there? I don't have them.
I think we're going to move on, but we can circulate all of these and we can fill it in to everyone after the workshop. Thank you very much, Sophie.
Okay.
Okay, I'll share for Breakout Group 3. So Roland, are you there?
Yes. Can you hear me?
Yes, we can.
Okay. So we had a lively discussion. So we several or many good inputs. So of course we capture the key elements. So don't be shy. If we miss something, we can implement further action. And of course it needs further discussion. It's just the start. So for the question, issue, and challenge that we discuss in the group, and we have mapped. So we have the state of play that global model community and regional model community are making developments to and advance on the capacity to predict and project climate change. And these developments are not aligned so far. So it's a key question and an issue so far when we are trying to connect and to speed up the process between those communities, because the level of complexity, the level of comprehensiveness of those two platforms are not the same, and it has an impact on the realism of downscaling global climate with complex model with regional climate that doesn't include the same type of processes. So that's the first item. The second item deals with the question of the fit for purpose between the model that we are using for global climate projection and the one that we are using for regional climate downscaling. And with this, with the emergence of new technology like machine learning or hybrid model, but also high resolution model. And the question we had on this is the fit for purpose for feeding the impact community that are organized across sectors, for which sectors the question of the timescale matters more than the model itself. So are the new tool aligned with this timescale and the requirement of downstream users? We have no idea so far, but it might be good to have further discussion on this aspect to feedbacks on the upstream community. Then we flag the point, and it's an easy one. So far, the downscaling community use a single ensemble realization. So that was included in the table from Sven for benchmarking global ESM, and we have now a bunch of knowledge and a bunch of literature on the role of climate variability, storylines, and so on. So it's a clear avenue to progress on those aspects to include more ensemble realization for benchmarking global model to feed downstream community. And then the last point is the research foci. CMIP in each round, CMIP 6, now CMIP 7, as taking a role in defining the scientific foci. And we are not sure at this stage if those scientific foci align with the scientific foci of CORDEX and ISIMIP. So thinking about alignment in scientific foci between those communities is also an avenue for spinning up and building up a cross fertilization across those communities. For the collaboration, of course, we need to foster collaboration. So that's the start. And of course, we need everyone. So that was an easy one. Then on the suggest section and the next steps, so 4 points. The first one is in our breakout, we have no feedbacks on the question about machine learning and AI community. So we need to engage them on those aspects to have people that are knowledgeable on this aspect, which was missing. And then we need to coordinate on quick question about selection criteria when considering emission-driven and high-resolution simulation. So that's something that needs to be considered when the data will be available. And I guess that will be after the realization of the fast track. And to have a common understanding on the needs for using more than one ensemble members. And the last one is to integrate and leverage opportunity with the rapid evaluation framework to support consistent evaluation across model types. And that is clearly something with a nice avenue. And I stop here.
Thanks, Roland. We'll need to move quickly on to Michael and Beth. So we'll probably need to be a bit faster. So the slides, because I know it's getting late for people. I'll hand over to you, Michael.
Yeah, we'll be really quick. Unfortunately, we didn't kind of put it strictly into the template, but we had a really nice discussion. And I guess our key takeaways are be really careful about what uncertainty means to different groups and what's important to quantify for what purpose, and then being aware of model selection as part of a broad chain of processes and decisions, not in isolation, because that's what matters at the end of the day and matters to users is the overall characterization of uncertainty, not just one step in the chain. And then making sure that the selection is part of an overall strategy of ensemble design and that the ensemble is doing what you want a model ensemble to do. And in terms of learning from statistical design kind of criteria and so on. Then we kind of had a nice discussion about how it's different for different regions and how to kind of account for different regional drivers and processes. We also had a discussion about how a big barrier is how uncertainty is imposed upon the selection, because some models don't provide the data, or some models just don't simply have lakes, and if an application needs lakes to be resolved, and then you can't use that model. Any opportunity to reduce that kind of imposition of choices would be helpful. And then we also had a quick discussion about what's actually most useful for applications, impacts, and decisions at the end of the day, including the good use of the storyline approach is really promising, but not easy, but it can be a really useful tool. But then also fully understanding what quantities and uncertainties are relevant to a application or a decision, and framing the uncertainty characterization around that can be really useful. And just keep our scientific curiosity alive, which was a nice kind of big picture point that was made. Thanks.
Great. Thanks, Michael. Sophie, you're up next.
Awesome. I'll be super fast too. It was nice because we had both end users and also GCM providers, which was perfect because there was discussion about the constraint on the availability of the required GCM ECM. One of the points that was raised earlier is that getting communication from the modeling centers would actually help a lot to the end users. And so that's something that would be really, really, really awesome. And so that's basically the key point to take away. And then therefore a question too is that because a lot of the development that the selection that we're doing is based on variables, would it be helpful for the modeling centers to actually know which variable we're kind of prioritizing, because then they can just push those out earlier, and because sometimes you have to wait for a variable to come and it's not there. So then maybe we'll move to the next slide, just to kind of be super fast. It was awesome for CMIP 7, all of this, engagement with the community compared to CMIP 6. So we're very grateful about that. And so I think a lot of issues, hopefully, that we had faced before will be resolved because of this. And so thank you very much. And therefore, really, we need to also be more aware about what's already there before we complain and join those groups, right? So next slide. Next steps, really trying to get, again, this modeling centers, information from modeling centers about what simulations are planning to run, are they running behind schedule, which variables are planning to deliver, when, and yada, so that, and the delays in those timing. And also maybe a little score count, so it's easier for us to understand there's changes between different models, model development between different CMIPs that we need to be aware of, because if we know we're going to be in a crunch, we're going to do a lot of our work based on CMIP 6 and hope that we can apply the same criteriums maybe for CMIP 7, but there is a massive difference in the model development, then that's a problem. So maybe I'll stop here.
Great. Thank you very much, Sophie. Next up, we have Michael again.
So we tackled the infrastructure needed to support use of climate projections and climate model outputs from the storage through to end users. And I guess we had a nice discussion about the whole spectrum and how storage of huge volumes is a huge issue, and how do we manage this efficiently, and how you can maintain it is just a big and a growing issue. And it's different for different levels of data: raw data, derived data, data that goes into a online web server versus what gets onto a web portal, and so on. All of these have different requirements, different needs for guidance, standards, and infrastructure. What we call data normalization or standardization is just always an ongoing issue. Like common grid, common variable names, common metadata can always be better. Then also we talked about how the use of big data in areas with poor internet or poor computing infrastructure, it's a very big barrier. So enabling online or server-based analysis is a matter of having the data available, but also the compute available, so that then people can have equitable access to the data, and also the ability to do analysis and derive it, and then only use download for the the final or small derived indices that are needed for applications is something that I think we can, that should be tackled at all levels, but including at the CMIP and CORDEX level, that kind of use of it. Maybe just click to the next slide. Yeah, we thought that collaboration between CMIP and CORDEX is kind of there, but could always be better. But then to these other platforms or other groups, like apparently accessing ISIMIP is different than CMIP and CORDEX, can be a barrier. And so collaborating there would be useful, but also this collaboration on enhancing the cloud computing, next steps for a lot of applications. People who want to use ZAR data into an Amazon Web Service or Google Cloud or things like that, kind of making that sure that that can work together. Would be useful. Maybe the next one. We had a few different solutions. Some of them were quite specific, standardization of various aspects of the data, storage, masking, precision, and things like that. But maybe I'll leave those as something you can just read for yourself. Yeah, thanks.
That's great. Thanks, Michael. So next up we have Christian again. I'll just share breakout group 7.
Yes, thanks. So this breakout group was about the question, how can the process from the production of the global simulations until the data information is provided to the end user be optimized and also speed up. So first there was the question why there was such a delay between the provision of the global runs and then the downscaling, at least in Europe, and there are several reasons. So one reason is certainly that it took some time to develop this this GCM selection framework that Stefan explained at the beginning. And then also we decided to include transient aerosol into the RCMs, which took time to develop for the groups, for the RCM groups. And then certainly there is also sometimes a lack of resources because the whole process is not as operationalized as it maybe should be. And yeah, I think, and also one point was that the global simulations came very close to the IR6 deadline, so there was no room for CORDEX to provide the simulations in time for IR6, and then there was no real pressure to do these things fast, and then it got delayed. So I think these were the main reasons why there is such a delay in the CMIP 6 downscaling. And yeah, then one question was, or basically Paco asked if statistical downscaling and machine learning shouldn't have a bigger role in this, because this would allow to provide data faster. But this is at least to a certain degree already covered for the CMIP 6 downscaling. This will be part, but of course let's say the ecosystem of end users is always very diverse, and therefore it's certainly necessary to provide specific solutions and information in the end, and therefore these things can of course be important. Yeah, and then of course it's clear, I think the CMIP and CORDEX communities, they have to work closely together and connect also with ISIMIP and probably also with Destination Earth to come up with a homogeneous framework here, and this is certainly also important. Yeah, I think the ML topic I already covered. Yeah, the role of the collaboration and who should be involved. What are the strengths of the different communities and how can they be brought together? Yeah, and yeah, all the different communities certainly need a structured framework to be able to collaborate. I think that's clear. Maybe I don't know if I missed something here. You can maybe add. So this was. Yeah, and possible next steps. Of course, tools are important. So quality checker is one part here before the data is published, to make sure that the data is really ready to use when it is online. But it's not only the quality checker. I think there are many tools necessary, and the things need to be as automatic as possible to guarantee a fast workflow here. And then this is also true for the criteria and the common indices that are necessary to do the model selection. And there it's certainly possible to rely on the ISIMIP tool and the rapid evaluation framework that will be available in CMIP 7. So these things are already there, and they can certainly be used and be the basis for these activities. The next point was already covered, and of course the standards and practices that we need for the machine learning and other tools is also a topic. I think Roland mentioned this in the end, that these things are maybe still or there are still open research questions that need to be answered until data that is produced with such tools can really be used and provided to end users. Yeah, I think that's it.
Thanks, Christian. I'll just stop sharing and hand over to Helene and Sarah.
Hi, thanks. I'll be quick because it's we're now running over time. So we were talking about balancing competing needs and the global community effort, and a few things we talked about. We talked about the funding context. So a lot of CMIP is mainly voluntary or in kind. One exception to this perhaps is the rapid evaluation framework, which is a lot of the work on that, because it's a very particular thing, is funded by ESA and the US Department of Energy, and it'd be, perhaps that's something we can broaden as well. We talked about whether that generally regions are struggling for funding, that maybe if the criteria for the choices is too long, some of the modelling centres won't want to participate or have their model part of the selection process. We talked about whether WCRP could pool its funding and resources to try and to maximise its efforts. Then we talked a bit about ensuring a process that's inclusive for all the CORDEX regions. Everybody knows there's regional imbalances. We saw that the Digital Earth Hackathon, which is coming up, is a good model for trying to build an inclusive process, although unfortunately no hub in Africa now for that, but in many other parts of the world. There's also no ESGF for Africa, or perhaps we need to work more with the data access task team to look at other options for data access for the CMIP data, and therefore the regional downscaling. So we go to the next slide, Sarah. And then just a few suggested actions. So WCRP, investigate pooling resources. CMIP, perhaps we can go back and look at the status of the data access task team and the options outside the global north again. And as many people have mentioned, the actions on machine learning and AI, this really has a role to perhaps make things more accessible and cost effective to the global community.
Thank you very much, Helene. We are now over, so just in terms of next steps, we'll leave the Padlets open for maybe around 10 days so people can reflect and go back and write comments. Tomorrow I'll put up the recording of the sessions. It won't have the breakout sessions, but the main plenary sessions, and circulate the slides. And then the sort of our organising committee, which is across CMIP and CORDEX and ISIMIP and ISIMIP and GlacierMIP, we'll maybe work together to bring all these ideas, which have been a huge amount tonight, and try and pull out some key strands that we can take action on. I think there's some opportunities to have some further discussions, potentially some in-person opportunities as well. So I think we need to look at where we can have that, because it would be good to to kind of break down some of these different actions and really get in deeper into them and have some tangible output. So thank you very much. Apologies again for the breakout sessions, for abandoning you all who got left there. But I hope everyone got a lot out of the discussion tonight, and you're now released after quite a few hours. So thank you very much, and we'll be in touch.